Hello class. I wanted to go ahead and do this video for you for the midterm exam. Hopefully this is helpful for you. So number one, since we see that the denominator has a 4 in the power, we're going to try to convert that 16 into something that has a power of 4. And I think 2 to the 4th is 16. So 2 times 2 is 4, times 2 is 8, times 2 is 16. That is right. And then I know by the power rule that I have 4 times 1 times 5/4. That's going to give me, not 4. That should be a 2. I'm sorry. 2. I'm going to get 2 to the 4s will cancel to the 5th, and then 2 to the 5th is going to be 32, and that's my answer, this first one. The crux to this problem, though, is to see if I can write my base number to have the same exponent as the denominator in the exponent that's being raised. Okay, in this next example, let's see, we're going to have to break up that 192. So the way I'm going to write this is in like powers of 5. So let's see, I'm going to break down that 192 real fast. So 2 and, what would that be? 9, 6, and then 2 and, what is that, 48, 2 and 24, 2 and 12, 2 and 6, and then 2 and 3. All right, so we can see 1, 2, 3, 4, 5, and then 6 remaining. So I'm going to go 2 to the 5th times 6, right? And then w to the 5th, w to the 5th, w to the 2nd. And the reason that I did that is because each 5th power will come out once. So I'll get 2 times w, and then what's left inside of the root is going to be my 6 and my w squared. So that's going to end up giving me an answer of 2w squared to the 5th root, or 5th root of 6w squared. I should say that correctly. So here's that, and that's the answer to that one. In this next one, we did this in class. Remember, we wanted to have the roots being the same, and so what we're going to do is I'm going to go 3z, and then 16 times 2 is a square, and then z, plus over here I'm going to be able to go 9 times 2 times z squared times z, and we see that that's going to give me, I'm going to be able to pull out a 4, so 3 times 4 is 12, and I'm going to have that z, and then root 2z, plus the square root of 9 is 3. I can pull out a z because of the z squared piece, and then what's left inside is 2z. Now, since the roots are the same, I can add these, right? Because they both have a z outside and the roots are the same. So 12 plus 3 is 15, z root 2z, and that's the answer to that one. Okay. This next one is just like distribution. So what we can do is we can go 3 times 4 square root of 10 is going to be 12 root of 10, plus 3 times 2 is 6. Then minus 4 times 4 will give me a 16. And then I'm going to get 2 times 10 is 20. And then minus 2 times 4 is 8, root of 2. And then what we're going to try to do is see if we can combine anything. So let's see if we can combine anything. I don't know if we really can. So what's going to end up happening is I'm going to have 12 root of 10 plus 6 minus, and then that can be broken down to a 4 and 5, right? So square root of 4 is 2, so that's going to be 32 square root of 5 minus 8 radical 2. And then there's nothing there to really be able to add up, so that is my answer. Because the roots aren't the same, I can't combine anything. But the trick there is just to distribute. All I did was go 3 times the 4 and then 3 times the 2. Should write that better. Times the 2. And then went this way with that to be able to get those numbers. All right, to rationalize this denominator, one of the things that you need to do here is multiply by the conjugate. And when you multiply by the conjugate, top and bottom, on top we're going to get a negative 15 plus 6 root of 3. And in the bottom, it's just the two numbers, the first number squared and the second number squared. So I'm going to get 5 squared minus 2 radical 3 squared. So that's going to give me a negative 15 plus 6 rad 3. I'm going to get 25 minus 4 times 3 is 12. And so I should get 13 in the denominator, and this is my answer. All that happened here, just so you know, is a minus b, or in this case a plus b, times a minus b, and that's a squared minus b squared. That's how I got this denominator piece. All right, number 6. It's asking us to solve for y, where y is a real number. So in order to do this, we're going to have to square. So I'll square this side, which means I got to square this side. So I'm going to get y squared minus 8y plus 16 is equal to a negative 3y plus 30. And then moving everything to one side, I'm going to get y squared minus 5y minus, looks like 14 is equal to 0. So that's going to be y minus 7 and y plus 2. So y is equal to 7 or y is equal to a negative 2. But we should check. And our numbers are these. Right? So if we plug in a 7, that's going to be a negative 21. That would give me a root of 9. And 7 minus 4 is 3. So this one does work. Let's check the other. If I plug in negative 2, I'm going to get 6, 36. That would be a positive 6. But on the other side, it'd be a negative 6. And so this one does not work. So whenever you do these problems, the one thing you have to be careful of is there are the possibility of what we call extraneous solutions. So just be very aware of that so that you don't run into issues with that at all. Okay? All right, the next problem, it's just distribution again. So I'm going to go 5 times 3. That's going to give me 15. 5 times 2i, that's going to give me 10i. And then negative 5 times 3 is going to give me a negative 15i. And then the negative 5i minus the negative 2i is going to give me a plus 10i squared. Now, one of the things you need to remember is I squared is negative. So I'm going to get 15 minus 25i minus 10, which is going to give me 5 minus 25i, and that's my answer. Don't forget, I squared is equal to negative 1. That's a idea that you need to be able to remember and do. Okay, it says find all complex solutions to this. So this isn't factorable, so this means we need to use a quadratic. So we're going to get a negative 5 plus minus the root of 25 minus 4 times 1 times 7 over 2. Oh, it is factorable. Silly me. So let's see. I'm going to get x plus... no. I must have done something wrong. That's funny. Okay, negative 5 plus minus 25 minus 4 times 1 times 7 over 2. And that's going to give me a negative 5 plus minus the root of 25 minus 28 over 2. So that's going to give me a negative 5 plus minus a negative 3 root 3 over 2. So that's going to give me a negative 5 plus minus I root 3 over 2. And that is your solution. Remembering that negative 1 in the root is I. This is not cute. So that should be a negative 5. And this is your solution to this problem. Okay, next one. We're going to try to factor and see what we can do. And so in the numerator, I think we're going to be able to go 7x and x, and I think it's going to be 5 and 1. I needed 2, yes, because 7 times 2. So I'm going to need this to be minus and this to be plus over, pull out a 5, I'm going to get x plus 2. And then I'm going to flip this one. So I'm going to get x plus 2 up here over, and then this is going to be 7x minus 5, 7x plus 5. And we can see this will cancel with this will cancel with this. And so we should get 2x plus 1 over 5 times 7x plus 5. And that's our solution. Remember, when you divide by a fraction, you need to multiply by the reciprocal. So that's what happened here. When I changed it to multiplication, I flipped it. Okay. This next one, we're going to be adding, and so we're going to have to be able to see what the factors are to be able to add, so we have common denominators. So let's see if we can do that. That's going to be a 5, that's going to be a 1. This will be plus and minus. Plus, this one will be 1 over 3x. What am I going to do? I need 14. Oh, there it is. 5 and 3. And they're both plus. So we can see the things that they have different that we need. And I'll write it in a different color so you can see it. This one needs x plus 3. So I have to put x plus 3 above. This one needs x minus 1, so this will need an x minus 1 up above. And so we're going to get 2x plus 6 plus x minus 1 over 3x plus 5, x minus 1, x plus 3. And then that's going to give me 3x plus 5 over 3x plus 5, x minus 1, x plus 3, which will then clean up to be 1 over x minus 1, x plus 3. And that's my solution. Noticing that the numerator and the denominator have something else that will end up canceling. Okay, so our next example, it's more of the same, finding that common denominator issue. So this will be 6 over x minus 4. This will be 2x minus 4, x plus 4, and that's because they have they're a difference of squares. And so we can see this one needs the x plus 4. So that means that needs x plus 4. And so that's going to give me a 6x plus 24 plus 2 all over x minus 4, x plus 4, which is equal to 1 over x plus 4. So that's going to clean up to give me 6x plus 26 over x minus 4x plus 4, which is equal to 1 over x plus 4. And then to solve this, we can just cross multiply, which is going to give me 6x plus 26 times 6 plus 4, which is going to be equal to this piece here. Such a bummer. There's an actually easier way to do it. In fact, I'm going to show you the easier way to do it because I'm going to save myself some time. If we notice, the right equation needs, so it looks the same, has the same denominator. All I need is x minus 4. So if I do this as x minus 4, now I don't need to worry about the denominator, and I can say 6x plus 26 is equal to x minus 4, which is going to give me 5x is equal to a negative 30. So x is equal to a negative 6. Cool. And there's my answer. That's for number 11, just so you guys can believe me. I have the answers here. There it is. It's a negative 6. I just did it a different way. I made the denominators look the same. Okay, so the next problem is working together. And what it says is left together, the cold water and hot water faucets of a certain tub take 6 minutes to fill the tub. If it takes the hot water 14 minutes to fill the tub by itself, how long will it take the cold water to fill the hot tub or to fill the tub? So what we're going to do is it takes, to fill the whole thing up, that's 1. It will take 14 minutes to do it with the hot water. With the cold water, we don't know, so we're going to say to fill the whole tub up, it's going to be some t time that I don't know. But when they work together, it only takes 1/6. So what I'm going to do is I'm going to find common denominators. So I'm going to go, okay, that's t plus 14 over 14t is going to be equal to 1/6. Now what I need to do is cross multiply. So I'm going to go 6 times t plus 14 is equal to 14t. So 6t plus, what is that? 684 is equal to 14t. So 84 is equal to, take away 6 is going to give me 8t. So t is equal to 84 divided by 8. So t is equal to 10.5, and it was minutes. And there's my answer. The whole crux to it is it's the whole time divided by the amount of time it takes to do the work. So the one on top means to do the complete work. The number on the bottom is how much time it takes each individual to do the work, or how much time it takes to do the work per individual and together. So that's the setup for that one. Okay, so in this next one, it's saying graph the solution to this inequality. No big deal. So I'll do it this way. So I'm going to say x minus 4, x plus 2 is less than 0. So when does that happen? That's going to happen at -2 and at 4. And they're open circles at these things. And so we want to know when it's negative. So here's the way I do it. I'm going to go, all right, x minus 4, x plus 2, and both, right? So if I pick a negative number, this one's going to be negative when it's less than 2. So if I use like -10, that would be negative, that would be negative. But when I multiply them, I would get a positive, right? Because the two numbers multiplied together to be less than 0. So if I use a number like 0 for x minus 4, I'd get a negative. 0 plus 2 is a positive, so that's going to give me a negative. And then anything bigger than 4, they're both going to be positive, so this is going to be a positive. So we want to know where this inequality is negative. It's only negative between -2 and 2. And that's our solution for that one. Okay, remembering, here's the important thing, this is a product. So that's why I've got to check each individual one and then both together being multiplied by where they both end up equaling 0. Okay. So this example here, it's asking us to square first, so that's what I'm going to do. This is z cubed. So -3 squared is going to be 9, and then each one of those are going to multiply. So I'm going to get this. Now the crux here is when you multiply, like here it's called a power raised to a power, so those exponents multiply. But in this part, this next part, you're just going to find the same variable and then add the exponents. So I'm going to get a 9 and then the negative that's in front. And then there's an x to the first power and x to the fourth, so that's going to give me x to the fifth. Y squared and y to the sixth is going to give me y to the eighth. And then z to the third and z to the eighth is going to give me z to the 11th. And that is my solution. Crazy. All right, this next example, 12 divided by 6 is going to give me a 2. And then I have x to the fifth minus a -6 because of the exponent, right? The power rule of the exponent. And then y to the -3 minus a -6. And then I have z to the -2. And that's all I got. All right, so I'm going to get 2x to the 11th, y to the third, z to the -2. So that's going to be 2x to the 11th, y to the third over z squared. And that's my solution. These are just exponent rules that you should have seen in Alex so that you're well prepared. Hopefully this is helpful for you. Okay, do the next one. So they probably don't show you synthetic division, so I'll do it the long way. And here's how this works. All right, so I need to match the exponent and the coefficient. So I need a 2 and I need an x. So that's going to give me 2x squared because the 2x is going to multiply with the x. That's how I get this. And then 2x times 4 is going to give me 8x. And then I'm going to subtract them. So that's going to go away and I'm going to end up with 3x plus 16. So that means I need a 3. So that's going to give me 3x plus 12. And then subtract, I'm going to be left with a 4. So the quotient is going to be 2x plus 3 with a remainder of 4. And that's my solution for this problem. But the whole crux to this is to have it match the very first number in each sequence. So we had to match this one, then we had to match this one, and then once we didn't have anything with x's anymore, we couldn't go any further. All right. This one's asking us to factor, so I'm going to go 2v to the third plus 3 to the third. So this is a cubic, and there's a rule that tells me I get 2v plus 3, and then 4v squared minus 6v plus 9, and that's my solution. Now, so you guys know the rule. A cubed plus b cubed is equal to a plus b. Then it's a squared minus ab plus b squared. And the solution is same, opposite, always positive. We call it SOAP. So if I had had a cubed minus b cubed, it would have been a minus b, same, sign in between, a squared plus opposite, and then always positive. And that's the rule for cubics, just so you guys always have it. Okay, let's do word problems. These are so much fun. So it says in this problem that $12,000 is invested in a fund that returns 2%. So I'm going to go 12,000 times 0.02 plus something that returns 7%, but I don't know the amount of money, so I'm going to go 0.07x. And then it says together the group got 4% back. So we're going to go 12,000 plus some x amount that I don't know times 0.04. I'm good, but I'm not that good. 12,000 times 0.02 is 240 plus 0.07x is going to be equal to 480 plus 0.04x. So I'm going to get 0.03x is equal to 240 dividing by 0.03. 240 divided by 0.03 is 8,000. So we need to invest 8,000 at 7% so that the two amounts of money yield a 4% return. Okay. The two train problem. So there's two trains. Here's a train. Here's a train. They're going towards each other, right? And the gap between them is 192 miles. One train is going 75 miles per hour. The other is going 85 miles per hour. If they're coming closer and closer together, they're closing that gap. So that tells me that I'm going to know 75x plus 85x is equal to 192. That's 160x is equal to 192. So x is equal to 192 divided by 160. What is that? 1.2 hours before they meet. And by meet, I mean probably crash. Because if they're on a train, they're going on the same rail, it's not a good deal. But the whole point is the picture is the thing that makes it so helpful here, right? Having the picture makes it so very helpful. We see that the distance being between them is shrinking. So that means the two trains as they're coming together are actually working together to shorten that distance. So that's why I added them when deciding to solve for the amount of time. Okay, here's this next problem. We're trying to solve for W. So we're going to put things together. So probably the easiest thing to do is multiply everything by, just to make my life easy, I'm going to go by 12. So that's going to give me 12 divided by 2 is 6. So 6 times -3 is a -18W. Then 12 divided by 3 is going to be 4 times that -7 is going to give me a 28. 3 times W, 3W times 12 is going to be 36W. And just so you guys know, I'm talking about this with this. And then this last number with this, 12 divided by 4 is 3 times 3 is 9. And now I have no more fractions. So what I'm going to do is I'm going to try to see how simple I can make this. So if I subtract, if I add 9 to -28, I should get a -19. And then if I add 18 to 36, what is that? Is that 54? 54W? I believe that's right. Let me confirm. And then 36 plus 18 is that. So -19 divided by 54 tells me that W is -19 over 54. And let's see if I did that correct. Number 20. Yes, I did it right. So very cool. Okay. But the whole crux is to get rid of the denominator. And the reason I chose 12 is because 2, 3, and 4 are the denominators. And to get rid of them, 12 works perfectly. Okay, let's do this next one. So I'm going to have 5v minus 37 less than or equal to, and I'm going to distribute, so I'm going to get a negative 16 plus 12v, right, once I distribute. And now I'm going to move things so I can get a solution. So if I add 36 to that, 16 to that, I'm going to get a negative 21, which is less than or equal to 12 minus 5 is 7v. And so I'm going to get negative 3 is less than or equal to v. And so when I go to graph this, I'm going to go negative 3. Oh, it doesn't even ask us to graph it, but I'll graph it anyways. Negative 3, it's going to be a filled in circle. And then what I'm going to do is I'm going to shade the direction I'm supposed to go. And that's this way. And the reason I knew that was because I could plug in a number like 10. Is negative 3 less than or equal to 10? Yes, well, 10 is somewhere way over here. I know it's going to shade that direction. Okay, this next example, the very first thing that we want to do is add 52 to both sides. And so I'm going to get 3 absolute value of 7w is equal to, what the heck is that? 52 minus 13 is 39. And then I'm going to divide by 3, so I'm going to get absolute value of 7. W plus 7 is going to be equal to 13. And then W plus 7 is equal to 13. Or W plus 7 is equal to a negative 13. Subtracting 7, I'm going to get 6. Subtracting 7, I'm going to get a negative 20. And those are my two solutions for this problem. Here and here. And I'll prove it to you. Negative 6 and 20. And I got negative 6 and 20. Okay. This next example, so to get rid of the absolute value, I'm going to write it the exact same way. And then I'm going to write it by flipping and changing the sign. So now solving for it, I'm going to get y is less than or equal to 1. And over here, y is greater than or equal to a negative 5. So the equal tells me to shade in. At 1, I'm going to shade in. Less than tells me to go this way. Greater than tells me to go this way. And so my shaded region is going to be this plus the dots. And let's see if I'm right. And there it is. I hope this was helpful. Trying to get something out to you so you can see and use this to prepare for the exam. You do have till Friday, so don't rush in taking it, okay? I wish you all the best. Take care.